Hello everyone, welcome back. So in previous lecture we started the new chapter that is about the measurement of screw thread and gear, and I explained about the introduction to screw thread and the terminologies, and I was explaining how to measure the each of the terminology. I explained we were explaining discussing about the measure diameter, and in measure diameter I explained about the micrometer. Now there is another micrometer that is used for the measure diameter measurement, that is the bench micrometer. Now you can see in the figure the bench micrometer is having one measuring anvil, then the clamp and measuring head and visual indicator. Now what happens, one anvil is kept fixed and other can be moved. Okay, now the this visual indicator will gives the variation over here. Now first we will measure the standard cylinder and then we will measure the screw thread, and here's the screw thread is measured with the help of this measuring, and you can see the on the both side we will require this holding center. Okay, in between these the workpiece will be fixed or the screw is fixed over here. So both hands are held firmly and the measuring anvil is used, and the standard cylinder and measured anvil cylinder, we will see the difference between the both. The ordinary micrometer method has deficiency like the variation in measuring pressure, pitch error in thread, zero error setting. Therefore, for great accuracy and convenience, a bench micrometer is preferred, and the instrument was designed by the NPL to remove the deficiency inherently in normal hand micrometer. Now, in order to ensure that all measurements are made at the same pressure, visual indicator is used. That is, ensure the constant pressure for all measurements. Instrument has a micrometer head with a vernier scale to read to accuracy of 0.002 mm. It is used as a comparator in order to avoid the pitch error of the micrometer thread and zero error setting. A calibrated setting cylinder having nearly same diameter as the major diameter of the thread to be measured is used as the setting standard. So setting cylinder is held between the anvil and the reading is taken. In this machine, there is no provision for mounting workpiece between the centers and it is to be held in the hand. The cylinder is replaced by the threaded workpiece and again the micrometer reading is noted. Now the major diameter is given by D plus or minus R2 minus R1. R2 is the reading of the micrometer on screw thread, then reading of the micrometer on setting cylinder. Then this is about the major diameter. Now how to measure the minor diameter. So first there is a 2V method. Here there are 2V pieces. V-shape anvil are used and they are placed for measuring the thread to be measured, then the anvil to be set. First, we will have a standard cylinder which is equal to the minor diameter, and we will set the anvil to that reading, and we will replace this standard cylinder with the our screw thread, and we can measure the in minor diameter. So very simple to understand. So this is also measured by the comparing process using small V pieces which makes contact with the root of the thread. And the V pieces are available in the several size having suitable radius at the edges. The included angle of the V pieces is less than the angle of the thread to be checked so that it can be easily probed to the root of the thread. The measure of minor diameter by V piece is suitable for only Whitworth and BA's thread, British standard thread, which have a definite radius at the root of the thread. For other thread, the minor diameter is measured by the projector or microscope. Minor diameter we can measure with the help of projector or a microscope. So this is also one of the another method. Then the measurement is carried out on a floating carriage diameter measuring machine in which the threaded workpiece is mounted between the centers, and the bench micrometer is constrained to move at the right angle to axis of the center by V ball. Okay. The diameter of V piece play no important function as they are interposed between the micrometer faces and the cylinder standard when the standard reading is taken. It is important while taking reading to ensure that the micrometer is located at the right angle to the axis of screw being measured. The selected V are placed on the each side of the screw with the help of with their bases against the micrometer face. The micrometer head is then advanced until the pointer of the indicator is opposite the zero mark and the note is being made of the reading. Then the screw is then replaced by the standard reference disc and or a plain cylindrical standard plug of approximately the core diameter of the screw to be measured, and the second reading of the micrometer is taken. If R1, R2 are the first one is R1 is the micrometer reading for the standard cylinder, and threaded cylinder it is R2, so it will be minor diameter. Similarly, D plus or minus the R2 minus R1, the difference between the threaded workpiece and the standard cylinder gauge. Another method for measurement of minor diameter of internal thread is using this taper parallels. You can see there are two taper parallel and the micrometer anvil is over here. This taper parallel anvil are set inside this. For diameter less than 200 mm, the use of taper parallel and micrometer is very common. The taper parallel are pair of wedge having parallel edges, outer edges, and the diameter across their outer edges can be changed by sliding them over each other as shown in the figure. Very simple to understand. Then by using the rollers and slip gauges, we can use the slip gauges and these two rollers to measure the minor diameter of the thread and the major diameter of the thread. But we can here only measure the minor diameter. So this method is used for diameter for more than 20 mm diameter. In this method, the precision roller are inserted inside the thread and the proper slip gauge is inserted between the rollers as shown in the figure so that the firm contact is established. The minor diameter is left then the length of the slip gauge plus twice the diameter of the roller. Length of the slip gauges and two times the diameter of the rollers. So this is about the measurement of minor diameter. Next we will see about the measurement of the effective diameter or pitch diameter. For that we can use the micrometer method, effective diameter or pitch diameter. So here you can see the anvil end portion are having the shape similar to the screw thread so that they can properly fix inside it. So that's why it is called as the thread micrometer. Resembles the ordinary micrometer, but the special contact to shoot the end screw thread from that is to be checked. In this micrometer, the end of the spindle is pointed to the V thread form with a corresponding V recess in the fixed anvil. There is one fixed anvil. When measuring the thread only, the angle of point and the side of the V anvil, the flank of the thread should come into contact with the screw thread. If correctly adjusted, the micrometer gives the pitch diameter. This value should agree with the ordinary obtained by the measurement by outside diameter and the pitch from the following notation. So here the pitch diameter is equal to capital D minus 0.6403 p in case of Whitworth straight, where depth is equal to 0.6403 p and capital D is the outside diameter and p is the pitch. Now, the limitation over here of micrometer is that the micrometer must be set at a standard thread plug, and if not done so, in the first instance, there will be an error due to the helix angle of the thread being measured. When setting instrument to standard plug, it will be observed that the reading is not exactly zero, as previously inferred when spindle and anvil are brought together. For correct result, it is necessary to use separate thread micrometer for every size of screw thread to be gauged. Otherwise, there will be always small amount of error inherent in the thread micrometer. A big advantage of the thread micrometer is that this is the only method that shows the variation of the drunken thread. Then the one wire method, two wire method, and three wire method. First, we will see the one wire method. This method is used if the standard gauge of the same dimension as the theoretical value of the dimension over wire is available. First of all, the micrometer anvil are set over the standard gauge and the dimension is noted down. Thereafter, the screw to be inspected is held either in the hand or in a fixture. Then the micrometer anvil are set over wire as shown in the figure. We will put a wire on the thread and then we will set the micrometer. But for that, we will require the standard dimension wires. Okay. And the micrometer reading are taken at the two or three different locations and the average value is calculated. This value is compared with the value obtained with the standard gauge, and the resulting difference is the reflection of the error in the effective diameter of the screw. An important point to be kept in mind is that the diameter of the wire selected should be such that it makes the contact with the screw along the pitch cylinder. The significance of this condition will become obvious in the two-wire method as explained in the next section. So first the D is the size of the setting, then the as we know that the micrometer reading over the standard size and for the thread under the test. So the effective diameter will be given by this D plus or minus small d1 minus d2. If the d2 is greater than d1, then we will see the positive sign in the above, and if the d2 is less than the d1, then we will see negative sign. We will use negative sign in this. Then comes to the two wire method. Now in this method, the one wire is placed between the two threads at the one side, and here you can see this is the two wire over here one side, and on the other side two wires are used, and on the other side the anvil of the measuring micrometer contact the crest as shown in the figure. First, the micrometer reading is noted on the standard gauge whose dimension is nearly same as that of the obtained by this method. The actual measurement over the wire on the one side and the thread on the other side is given by the size of gauge plus or minus the difference in the two micrometer reading. Let the E be the effective diameter, H be the diameter over the wire, which is the maximum, and Y is the diameter under wire, that is the minimum, and small d is the wire diameter. And from figure we can see the Y is equal to this H, okay, minus 2d. यहाँ पे जो diameter है वो 2 times है, so Y is equal to H minus 2d. H is the diameter over wire, that is the maximum diameter. Then let the pitch value be the P dash, which depend on the pitch of the thread and the wire of the diameter, and we can write the effective diameter is equal to Y plus P dash, and we know the P dash, that is for the metric thread 0.866 P minus D. So here you can see in the figure, first we will measure with the standard size of the cylinder, and then we will check with the compare with the screw thread. Up to this we will keep today's lecture. In next lecture we will explain further. Thank you very much for listening carefully. Have a nice day.